Welcome, welcome. We'll start in a minute. Welcome. Welcome if you're coming in. Super excited to do some calc with you guys right before your AP test. Coming in, welcome. All right, it is 4:30. We're going to get started in like 30 seconds. Welcome to all of you coming in today. Great that you're here with me. I'm Elizabeth, and I'm going to be doing your stream today for BC. I'm super excited. All right. Got lots of content to get through, so I want to get started right away. My name is Elizabeth. I'm going to introduce myself in a slide in a second. If you're in here, this is for the second portion, the BC content of the CRAM. So we'll be going for 2.5 hours. Just a reminder, the stream is being recorded and might appear on our website, YouTube, or other public channels. If you want to change your name, there's no active chat in this one, but there is Q&A on the actual website. So if you want to change your name so that it doesn't appear to be your real name, make sure to do so. And just different ways to reach out to Fiveable. There's Discord, which you can use. We're on Twitter, we're on Instagram. So there are many, many, many different ways to reach us for Fiveable. All right, so this is what tonight's going to look like. We are on a tight schedule. I want to make sure to get you guys through the content. We're going to do an intro for about 10 minutes, and then we will jump in with Unit 6 at 4:40. These are all in Pacific Standard Times. And then I'll break it down from there. All right, so what we're going to cover in each unit. So we're going to cover units 6 through 10, just the BC concepts. Obviously, units 9 and 10 are totally BC, so we'll be covering those. We're going to do review, multiple choice, and free response. All right, just a little bit about myself. I live in Los Angeles. I've been teaching 6 years, BC 5 of those. I'm super stoked to be reviewing with you guys. I love to travel pre-COVID. We love to go camping, hiking, running marathons. Got 2 dogs, Katie and Kike, and I believe that anyone can be a math person. So that is kind of my mantra here. All right, so I would like to introduce Amanda. She has a quick message for us from Fiveable. So she is going to be coming in. Maybe not at this second, but soon. Okay, I'm going to keep going until maybe she comes. All right, while we're waiting for Amanda, I've got a warm-up question for you in the poll. So just a little bit about you. Would you rather, a tough question here to get started with, would you rather always be 10 minutes late or 20 minutes early? 10 minutes late or 20 minutes early? All right. Ooh, we're seeing lots of votes for early. All right. All right. Okay. Oh, wow. Everyone is almost overwhelmingly early. All right. Awesome. Okay. So give me 1 second. We're trying to get Amanda in here. Okay, so while we're waiting, just for Amanda just to get in here. Okay, so we're gonna start with Unit 6. We'll start a little early while Amanda is planning to come. Okay, she is ready. So before we start Unit 6, Amanda's gonna take over now and give us a short little snippet. Okay, guys. Give me 1 second. All right. Still trying to just figure this out for 1 second. Sorry, thanks for hanging with us. So we'll start with Unit 6. For Unit 6, you are going to, we're going to cover integration by parts, improper integrals, partial fraction integration. So just to refresh, these are the BC concepts in Unit 6. So integration by parts, there's 2 methods, ultraviolet voodoo and tabular, and we'll cover both of them. Partial fraction, there's rational expressions, there's a repeated factor, and there's a numerator that's larger than the denominator. So these are the 3 different types that you will see on the AP test. Improper integrals, just a quick snippet of information here. Remember to replace the bounds with a constant and then take the limit to infinity. Okay, so for tabular, or for integration by parts, there are a tale of 2 methods. One is tabular. You have an actual table here, right? You are adding, when you're going to pick one side that you're taking the derivative on, and on your other side, you're going to take the integral on. Okay. And then I will illustrate this one in a multiple choice question that we're going to do shortly. And then for this one here, this is your ultraviolet voodoo method. This one will always work. It'll work with every problem. It's not quite as fast as tabular, in my opinion, but maybe some of you are super proficient with ultraviolet voodoo method and can get it done super quickly. So you need to pick which a function for u and dv. You would set up a table. This is what your ultraviolet voodoo is. Ultraviolet voodoo is just a way, a mnemonic device to remember the u times v minus the integral of v du. And I will also demonstrate this in a multiple choice question. Some partial fraction reminders, quick tidbits. Remember to turn each rational expression into a sum of simpler forms. That's the whole process behind this, right? So you're going to divide up your fraction. You probably did this maybe in pre-cal, right? So now we're just adding a layer to it, adding that integral. Something important to remember, if you have a repeated factor, so if it's like x plus 4 squared, make sure that your second factor, that you just don't put x plus 4 and x plus 4. You need to put x plus 4 and x plus 4 squared. If you don't put that squared when you're solving the problem, you'll realize you'll come up to a point where you're going to get 0. And you'll realize, oh man, I did something incorrect. So maybe if you're taking some notes tonight, I would star that. And if your numerator is larger than your denominator, make sure you long divide first, right? It's going to be super difficult to do it otherwise. Okay, and there are improper integrals. Just a refresh, again, these are ones when your integrals are going to positive infinity and negative infinity. I think it's helpful sometimes to visualize a graph when you're looking at this, right? Since there is no bounds. We will go over this on a multiple choice question as well, but just want to give you a quick refresh of what that's going to look like here. Okay, here we go with our first multiple choice question. I would have a pen and paper handy right now because we are going to go through a bunch of questions, a bunch of free response, and I want you to practice timing yourself as well. Okay, so I'm going to give you 2 minutes now. That's about the time you would have for a free response, excuse me, for multiple choice, depending on the section. So if it's a calculator section or non-calculator section, the time is varying between like 1 minute and 30 seconds and 2 minutes. All right, so go ahead and try this problem. I'm going to open up a poll. So when you feel like you've got your answer, you can go ahead and drop it in the poll. About 50 seconds left. So I'm going to hide the poll. Feel like you've got your answer. Twenty seconds. All right, I would love for you to take a guess. Drop your answer in the poll. What are you thinking? A, B, C, D. Your answer in the poll. Okay. All right, let's take a look at this question. Okay, so for these questions here, when you have an improper integral, you want to replace that improper bounds with a limit, because we know we can't take the limit to, or excuse me, we know we can't take the integral to infinity. If we're thinking about our graph, that's going to make it a little difficult, right? So we are going to integrate this. We've got our u sub that we would need to do for this problem, right? We're doing our u sub. And then, oh my goodness, I see this x dx here, and right, that would perfectly match. So that means I picked what I needed for my u sub. I did that correctly. And I'm ready to go to my next step. So then this would become 1 over u squared times 1/2, since I have this over 2u. And you could bring that to the front, or you could put it, I'm just putting it in the integral for right now, right? Okay, I'm going to take my integral. I know that's negative 1 over u, b to 1. Then I am plugging in infinity. I'm going to get rid of that limit. I'm plugging in infinity, and I'm plugging in 1. So that would give me, if I solved all of this out, that would give me 1/4. So this solution to this problem would be C. The solution to this problem would be C. Right. Again, if this is on multiple choice, like this is a practice multiple choice question, you don't need to show all this work. No one's looking at your work, right? So don't worry about showing that much work, and using the correct notation on multiple choice saves some time for yourself. Okay, let's go to our next one. Here we go. We have got, whoop, that's not the next one. Okay. Here's another practice AP question. 2 minutes. Go ahead. 2 minutes. Okay, the poll should be working now. Thank you, my lovely TA. It's helping me out. Appreciate you. Okay, so put an answer in. We're looking like a little B, a little C. Great. All right. Let's see. Okay, awesome. I love that. Some of us, you know, you might not even have finished the problem, but at least like you're putting in an answer, you're going for it. That's awesome. Okay, so if we look at this problem and we go over this, this is an integration by parts problem. This is an integration by parts problem. So we can either use tabular or we can use ultraviolet voodoo. I picked tabular for this problem because tabular is a good one to pick when you have a derivative that's going to go to 0. So part of my function, this x here, this is going to go to 0, right? If I keep taking the derivative of it. So I know that I'm going to put this on my derivative side. So my derivative will go to x, 1, and 0. My other function is the one I'm going to be doing the integrating with, this sine 6x, sine 6x. So if I'm integrating this here, I'm integrating sine 6x, that'll give me negative cosine 6x over 6, and then negative sine 6x over 36. The trick or the tools to use tabular is you create a pattern. So you're adding and then you're subtracting. And if there's more than 2 lines, you continue the pattern, but you always start with adding. So this first term would be positive if we're combining these terms. Actually, I'm sorry, let me reframe that. These are going to be positive and negative signs, not addition and subtraction. So this is going to tell you it's positive. So it'd be positive x. times negative cosine 6x over 6, which would give us negative cosine 6x over 6. This one is going to be a negative sign, so 1 times negative sine of 6x over 36, which will be positive. Okay. So again, let me just reframe that. It's not adding and subtracting, it's a sign. It's going positive, negative, if you're using tabular. So the correct answer for this would be B then. The correct answer for this would be B. So all of you that put B, awesome job. Again, maybe a tip for this problem, you could probably cross off A and E, even if you have no idea what you're doing. They're totally different from any of the other ones. So you can narrow it down to B, C, and D. Okay, and at least have, you know, those 3 to work out of 5 instead of out of 5. Okay. Go. All right, here is another problem, and I will post up the poll in a sec. Go ahead and start. Okay, the poll is open. And it only lets me put 4 answers, so you're welcome. I eliminated one for you. Another 20 seconds. Ooh, we are feeling strong on this one. Feeling strong. All right. Yes, getting it. Freaking awesome. All right, guys. Well, if you are looking at the poll and you selected E, you are correct. C is also a very tempting result. It is also very tempting. So if we look at this problem, again, this is a integration by parts problem. We could do ultraviolet voodoo, or see, we could do tabular, but I want to illustrate ultraviolet voodoo for this one, as this might be one you're familiar with. So with ultraviolet voodoo, you need to set it up where you're picking your U value and you're picking your DV value. You're picking your U value, excuse me, and you're picking your DV value. So I would much rather take the derivative of x and it goes to 1, right? And I'm going to integrate secant squared because, yes, that looks super familiar to one I'm sure your teachers told you over and over to memorize, right? So I'm going to select that. I know that it's ultraviolet voodoo for my mnemonic, my little trick that I got going on here, okay? So I'm going to plug in what I know. I'm plugging in x tangent minus tangent x dx. All right, okay. All right, so I'm going to I'm going to rewrite tangent as sine over cosine, because I don't know about you, but I don't know off the top of my head the integral of tangent. Maybe you do. I don't. So I would then do u sub. So I'm going to u sub my cosine of x. And oh my goodness, I did something right because I see a sine dx here. I've got this negative, so I'm going to need to put that negative in the front. So then I'm going to change my integral. I'm going to make it a positive 1 over u. Take the integral of that, x tangent x plus ln. I know the integral of 1 over u is ln. I'm substituting u back in for cosine, and voila, my answer would be E. Perfect. D is also a close choice. I probably shouldn't have eliminated D. I should have taken out like A or something else for you guys. So if I were taking the AP test, again, quick strategy, I'd look at my answer choices. I could probably take off this one, maybe C too, so it'd probably be between D and E if I'm just thinking about like time-saving strategies. Okay, here we go, another multiple choice question. We've got some integration by parts. I'm gonna cut us off a little bit earlier this time. Probably at a minute. There is a distractor answer in here, so be careful. All right, I'm gonna cut us off here. I know that was not nearly enough time for integration, a partial fraction integration problem. Those take quite a bit of time. Okay, so oops. I know that this is going to be partial fractions. I see my rational expression. There is some distractor answers in here. I'm seeing a lot of us selected B. B, you did everything right except one little baby step at the end. Even C, you're super close too. Okay, super, super close. All right, so I'm going to break up my partial fractions. Again, this is a multiple choice, so notation, no one's going to look at it. You're trying to answer as many questions as you can and you feel confident with, right? So I've got my A, and over my B, I'm breaking up my fraction. We'll just look at the blue for now, ignore the black. Writing over here. So we're going to, we need to find a common denominator. So I'm going to multiply my A side by x plus 2 and my B side by 2x minus 3. That equals 7. It's got a common denominator now. So I'm just going to eliminate it, take it out, because everything's under the same. So I'm just working with my numerator. I need to find what my A and my B values are. So for my A, I'm going to set x equal to -2. That'll eliminate my A value. Okay, so then my B value is going to be equal to 2. I'm going to do the same for the other problem. I'm going to set it equal to x equals 3 over 2. So my A will equal 3. I'm plugging this back in. Now we can look at the black writing on this side. I'm going to plug it back into my integral. And so close here. That's why if you picked B, you were super close. You just forgot. When you're integrating this, be careful with chain rule. You're really doing it every time. Every time you take the integral of 1 over something. But we would need to do some u sub with this, right? So u sub is equal to 2x plus 3. The derivative of that is going to be 2 dx. So that means you're going to need to divide by 2. So the answer for this one would be A. Answer for this one would be A. So you were probably super, super close. All right, to wrap up this section, we're going to do this FRQ. We're going to do this one together, actually, instead of giving you time. We're running a little bit behind on time, so I want to make sure that we're sticking with our schedule. All right, so this is a 2015 FRQ, a 2015 FRQ. This is just part of, I just snipped part B because that goes with what we're doing in this section. So here it's saying, it's giving you this information about your function, which pertains to the other parts of the question. It's saying k equals 6 here, find the partial fraction decomposition for this integral. So we want to look at our fraction here. I notice I can pull out an x right away. So x minus 6 over 1. Then I'm going to make my a over x, plus my b over x minus 6 equals 1 over x times x minus 6. I need to multiply my a by x minus 6 and my b by x, and that'll equal 1. Put my work up here. I want to set, let's set x equal to 0. If I set x equal to 0, that's going to eliminate my b. So I'm going to be left with negative 6a equals 1. So a will equal negative 1, 6. I'm going to set my x equal to 6 to eliminate my a. So then I'll be left with 6b equals 1. So b equals 1, 6. All right, then I write it as an integral. So I've got negative 1, 6 over x plus 1, 6 over x minus 6. Don't forget my dx, super important. Notation there, notation, notation. And I'm going to integrate. So that'll be negative ln x over 6 plus ln x minus 6 over 6 plus c. And that would be the solution to this problem. And we can check out the scoring guide. See what that scoring guide is telling us. Make sure we got all our points. So we would get 2 points for our partial fraction decomposition. We showed all our work in our work as well. And the general antiderivative, which we found here. Either one, they would give you credit. Remember, you do not need to simplify on the AP test. It's a test to assess if you know calculus, not if you can simplify. All right. Whew, that was a lot of math. Quick brain break here. Quick brain break. Here's a Taylor Swift meme with Taylor polynomials, which we will get to. All right, we're close to being on track. We're 4 minutes over, so the next 15-minute chunk we're going to be spending on Unit 7. Unit 7. Unit 7, the two BC concepts that are in Unit 7 are Euler's method or Euler's method. I've heard teachers say it both ways, and logistic growth models. So just to recall that information, a quick tidbit for Euler's method or Euler's method, make sure to make a table to organize your work. That's my preferred way to do it. Maybe you do it differently. That's fine. Whatever you do to organize your work. Make sure you're reading the step size carefully. Sometimes they have negative step sizes. Sometimes it's not a nice 1 or 1.5. Those are the two that I feel like they like the most. Be very careful when it's a negative step size. So read the question carefully. Logistic growth, memorize the general solution, memorize the differential equations, and remember what carrying capacity is. Maybe we'll talk about that. Okay, Euler's method, quick refresh. this is how I would set up a table. This is how I tell my students to set up a table. Maybe you do it differently. Maybe you just write out the equation. We'll go over a problem and I'll illustrate the table too. But this is how I would organize my work. Logistic growth. Remember, you have a logistic graph and it maxes out at a carrying capacity. So that's how many animals or people or whatever could live in that organism at that carrying capacity. We've got our general solution here, right? And these are what the variables stand for. P at population time T, L is your carrying capacity, K is your growth constant, and A is your constant determined by the initial condition. Logistic growth models. We have P is the population at time T, L is the carrying capacity, and K is your growth constant. Okay, so these are formulas to know. Maybe make a star in them, or if you're going back, write it down so you know. All right, here is our first practice question. This one's on Euler's method. Go ahead and try this one. Try this one. Okay, about 53 seconds. Gonna open up a poll for you. This is MC number 1, unit 7. All right, drop your answer in the poll. Okay, let's go over this one. I'm seeing lots of votes for C and D. C and D, we're a little torn here. All right. Okay, so if you picked C, you were correct. Awesome. Remember, just, even if you're not sure, go for it, try it. So I recommend setting up a table. Again, you do not have to. Some students last stream were talking about putting dy dx in instead of m, and I totally like that. So I incorporated that in this time. And then the change in x is your step size. So in this problem, it's telling you your step size is 1.5, and it's saying to approximate. So for this one here, I'm setting up my table. I know that my first value is -1, -2. My step size is 1.5, and my slope here is 2. I got my slope if I'm looking at my table here, right? -1, the slope is 2, so it tells us that right here. And then I'm adding my y old to my y new, which is 1, so that goes in this new position here. 1.5, I'm looking for my new step size, or excuse me, my new slope. So that'd be 0.5, 0.5, and that's going to be 1. So that will give me 2.5. If you got D, maybe you added an extra 0.5 somewhere. There might be just a small calculation error on your end, maybe. So just double check your work on that one. The first time I did this, I got 1.5, and then I had to check my work. So the table just kind of adds an extra layer, I think, too. All right. Moving along. All right, we're going to do an FRQ to cover our logistic growth. I'm going to give us 5 minutes instead of 7 or 4 minutes, so I'm going to stop us a little early on this one. Remember, on free response, do as much as you can, right? You never know what you're going to get credit for. Write as much as you can down. Okay, I'm going to give us like 1 more minute. All right. I'm gonna cut us off here. Okay, let's look at this FRQ. This one's from 2004, but again, these are totally always still relevant. The College Board tends to recycle questions a bit. I have the scoring guide here next to it, but we will also look at the scoring guide in a second. Okay, so if P0 equals 3, what is T to infinity? So we are looking at our carrying capacity here, so that would be 12. That should be 12. The same for 20. carrying capacity will also be 12. Again, this is just looking at the formula here, right? This is looking at the formula. If P of 0 equals 3, for what value is the population growth the fastest? This is where we have our point of inflection. Point of inflection. So that would be half the carrying capacity. Half the carrying capacity. So that's only worth 1 point. But, you know, it's 1 point. It's important to know. For C, it's asking us to separate the differentiable equation. If y equals t, y equals 0 equals 3. If I'm separating my variables, that would need to be dy over y. I'm moving my y to the other side. And then I would need to integrate my 1/5, 1 minus t over 12 dt. Right? And if I'm integrating, this will come to ln of y equals t over 5 minus t squared over 20. And we know to undo ln, we need to raise everything to the e power. Oops, don't forget our plus c. And then these would negate each other. So I would be left with y equals e t over 5 minus t squared over 20. And our k will go in the front. So our k is like our c, right? That is our constant. In this instance, our k is going to be 3. If we plug in, if we look at our question, it gives it to us at y equals 3. Our k will be 3. So k will equal 3. And you would write it again with the answer. So this one is worth 5 points. So we'll look at it on the next slide, but 1 point for separation of variables, 1 point for antiderivative, 1 point for constant integration, use of initial condition, and then 1 for solving for y. So this is a pretty big one. And then for part D, it's saying for function y found in part C, what is the limit as it goes to infinity of y of t? The limit as it goes to infinity of y of t, and that would be 0. Just be 0. All right. It's a lot, this one. Okay, we are moving right along. We are going to go take a quick puppy break. There's a video for us. We'll watch like 20 seconds of it. Okay, if you want to keep watching puppies, it's amazing. Puppies make everything better. All right, we are going to start on Unit 8 now. Unit 8. Unit 8 is arc length. So arc length, remember there are 3 different types of arc length. Two that we talk about later on, one for parametric and one for polar. In this unit, they're just talking about the regular parametric one. So this is the one in red is the one that you need to know for this unit here. And then in units 9 and 10, we of course add on our parametric one and our polar one. So these 3 are probably helpful to write down. So they're definitely helpful to write down in your notebook or on whatever you're using to study. Okay, let's try some of these. Here we go. Go ahead and try this one. Go ahead and try this problem. Okay, 20 questions. 20 seconds, not questions. Gotta drop a poll here. See what we're thinking so we could put our answer in there. As we're starting to go over it. All right, drop your answer in the poll. What are we thinking? Yes, awesome. Nice, guys. Great. We're looking overwhelmingly D, which is correct. D is correct. You have got it. Remember, this is your arc length formula, so I wrote it in green here. If you selected B, you are super close. I see lots of us are selecting B. You are close, but you just forgot to do this chain rule here, right? So we know we want to take the derivative of our function. So that's cosine square root of x times 1 over 2 square root x. Got to do that chain rule. Super important. Don't forget your chain rule. And then we're going to square it, right? So we're going to square it then. So I could immediately eliminate this one and this one. If we did chain rule correctly, we'd be left with E, C, and D. C is looking a little crazy. I feel like it's probably a distractor question, right? So I could cross off C. So my correct answer here would be D because it's 1 plus that value. It's not all under the same fraction. So 1 plus that value. Okay. Let's do another one. All right, this one you got to work backwards a bit. We're working backwards here. Length of the curve. Let me drop a poll in the chat. Got 22 seconds. Okay, let's look at this question. Oh, we don't want to go backwards. We want to go forwards. Okay, so this one here, we're working backwards. We know that our function is the derivative here. So the derivative squared. So we're going to undo that part, right? So we're taking out the squared aspect. So we know our function is just going to be 3x squared. So we're working backwards here. If we integrate that function, we got x cubed 3 over 3 x cubed plus c. Okay, we need to figure out what our plus c is going to be. We know in the problem, it told us that it's containing the 0.16. So that means our c value is going to be 5. So our answer would be B here. Our answer is going to be B. And we were kind of split, it looks like, on A. Not a lot of us picked D, which is good. I would eliminate those ones for sure. We could also probably eliminate A, right? Because if we're taking the integral of this, we know we have to increase that exponent. And then it should be between B and C, so just make sure to read the question carefully, what it's asking for. All right. Okay, we've got our last question for this unit here. All right, try as much as you can. I'm gonna give us, say, 4 minutes, so I'll cut us off at 3 minutes. Go ahead and try as much as you can for this one. Try as much as you can. Okay. Let's start looking at this one. Let's start looking at this one. All right, here we go. Here we go. Okay, for the first one, it's asking you to find the average value. Average value is just going to be, remember, that is different from average rate of change. So that is going to be, let me make this a little bigger. Not going to rewrite it just so we save a wee bit of time here. That would be 1 over 5, 5 to 0 is our function, and we're plugging it in. It's telling us from 0 to 5 that this value is going to be negative 10. In the problem here, it's going to tell you that it is 10. But we know that from 0 to 5, since it's below the x-axis, it's going to be negative. So that would be negative 2 for our first one. For B, if we want to evaluate this function, we would set it up like so. To get our negative 10 and 27 and 20, these values here, we need to look at our problem here. So it's telling us that the arc length of the portion is 11, the arc length of the portion is 10, is 18. Oh, I highlighted the wrong thing before when I was reading the area. Let me re-highlight that for us. Nope, it's not going to let me. Okay, there we go. It says the area region from 0 is 27. The arc length is 10. I just saw 10 and I got excited. I highlighted it for us. Okay, so for B, if we're going from 0 to 10, this whole area under the curve, we know that from 5 to 10, that area is going to be 27, right? A total of 27. The area below is going to be 10, right? From 0 to 5, 11. And so we would calculate it out like this. So you're using the information that is given to you on the graph. For C, it's saying on what intervals, if any, is the graph of G both concave up and decreasing? Concave up and decreasing. So we know from 0 to 5 could be one option. It's also increasing from 3 to 8. Okay, so our graph is increasing from 3 to 8. And it's decreasing from 0 to 3. I should use another color here. Trying to color code this for us. Okay, so the graph is increasing from 3 to 8. The graph is concave up and decreasing on this value because we know that this whole area is going to be going up. Remember, concave up kind of rhymes with cup, concave down rhymes with frown. Okay. And for this last portion here, this arc length portion, this is probably the most important part of this question because this is what is covered in Unit 8. It's telling you to take the derivative of this function. It gives you what the derivative is. Find the arc length of the graph from 0 to 20. Again, you're using the information in the problem to fill in and solve it. If we set up this problem, we are going to need to do some u sub here, right? So u is going to be x over 2 and du is 1 over 2 dx. Okay. And then if we're looking at our graph right here on the scoring guide, we can see that this is 1 over 2, but when we do our u substitution, we're going to multiply everything by 2. So this 2 here on the scoring guide, they're getting it and you're changing your bounds, right? So be careful when you're doing this problem, if you're pulling out that 2, that you are changing the bounds from 0 to 10 instead, okay? And then you're plugging it in with the information that is given, our arc length, which is 11 and 18. 11 and 18. Okay, That was pretty fast going over that one. Trying to do two things at once. Here we go. All right. Okay, and we went through the scoring guide. All right, quick brain break. Enjoy some nature pictures. All right, here we go. We're entering into Unit 9. We'll be in Unit 9 till about 6 o'clock Pacific time. So these are the topics covered in Unit 9. Everything is brand new to you in Unit 9, right? Everything is totally brand new. It's all about parametric and polar equation. Some important Unit 9 formulas to know. We need to know the derivative of our parametric formula, which is dy over dx over dx dt. Our second derivative is the derivative of the first derivative in our numerator, and dx over dt. We know our arc length formula here. We talked about it a little before when we went over regular arc length. But here then we have the derivative of your x function and the derivative of your y function squared. Okay, some polars basic that you will probably need in your toolkit for maybe some of these problems. This part is fairly basic. So from pre-cal, you probably learned this, but if you need that refresh, definitely write that down. Our polar derivative, this is a hefty one here, right? This polar derivative, so also maybe something you want to write down. We've got arc length, polar arc length. If you have one curve, polar arc length is up here. I don't know why I went down there. That's clearly area. Polar arc length is r squared plus your derivative squared. Polar area, those are these two down here. So if you have one curve, this is your polar area curve. If you have two curves, this would be your polar area formula. All right, so we are gonna do a FRQ for this one. So I'm gonna give you 7 minutes to go for this one. Try it. We got 7 minutes. Get as much as you can do done on this one. Okay, about 3 more minutes. There's a lot going on this one, and this is a no calculator one. Two more minutes. All right, 1 minute and 40 seconds. All right, 30 seconds, finish up. All right, let's look at this one. Remember, you do have 15 minutes per FRQ on the actual AP test. So don't, I'm only giving us 7 minutes right now so that we can get through maximum amount of content together. So if you're like, oh my gosh, this is too fast. Yeah, it totally is, right? I'm giving you half the amount of time. So just keep that in mind. I want to make sure I maximize our time together. Okay, here we go. So it says the graph of the polar curve R is 4 and R equals 3 plus 2 cosine theta. I would immediately label these, right? I would label them so I know which is which so that I don't get confused when I'm labeling them. It also gives you the points of intersection with, which, as you know, that is freaking amazing because my students hate finding the points of intersection, as do I. It's a lot of extra work, right? When it's not super neat or like just playing with the calculator, it takes a lot of time. So it gives it to you. For this one here, it's asking you to find the graph. You write an expression solving an integral for the area of R. So we're using that area formula straight up, just that area formula here. So 1/2 pi over 3 times 5 pi over 3. Our outer function, and that's why it's important to label so you can visually see which one's outer and inner. 4 squared minus 3 plus 2 cosine squared over d theta. That is it. It does not say to solve. So make sure you're reading the question carefully, right? You're not wasting time on something where it doesn't even say, you need to do it. For part B, you need to find the slope of the tangent line using only the graph 3 plus 2 cosine theta at pi over 2, right? So nice of you. They didn't give it they didn't just let you do the 4 one. Want to make it a little challenging. Okay, so that's where this formula comes in. Super helpful if this is not looking familiar to you. I would recommend writing, you know, maybe this is something you want to put on like your sheet that you're going to look at in the morning before you go into your AP test, or flashcards. If you're making flashcards, I would do that. So if I'm plugging in my information, I'm going to need to take this off. So it's going to look a little crazy, but just look at this line here first. We're plugging in our derivative of r, which is -2 sine times sine, and then r times cosine theta. Again, we're plugging in our derivative, -2 sine theta, plugging in all this, and then we're evaluating at pi over 2. Pi over 2 remembers on your unit circle. This one's key to know. Your unit circle is super important. Your pre-cal teacher would be so happy if they knew you're using your unit circle. So this would give you 2/3 here. That would give you 2/3. And we'll look at the scoring guide in a bit, but that would give you 2/3. All right, for this one here, there's a lot going on the screen, so I'm going to cover some up for us. Okay, here we go. So it says a particle moves along the curve. The particle is moving such a way that the distance and the origin increase at a constant rate of 3 units per second. So I'm writing on my paper, this is dr over dt equals 3. Reminder to myself, find the rate at which the angle changes with respect to time at the instance when the position of the particle corresponds to pi over 3. Indicate the units of measure. So this is important to remember. dr dt equals dr d theta times d theta dt. We know, we want to figure out what this rate is here. That is the goal. That is what we know. The goal is to find d theta dt. I highlighted it in red. My own color coding got me mixed up. I highlighted in red because all of these, this is the derivative of this. So that's -2 sine times d theta dt. So if we manipulate this equation a bit, we know that -2 sine theta times d theta over dt equals dr dt divided by -2 sine theta. Okay. So dr dt equals -2 sine theta divided by. All right, then I know I want to evaluate this function at pi over 3, okay? I know what dr d theta is because, oh my goodness, they gave it to us in the problem. A tip for free response, if ever you're solving a problem and you're like, I don't have this piece of information, I don't know where it is, it's probably hidden in the problem. So make sure to go back and read it. And then you're plugging in pi over 3. And your solution would be 3 over negative square root of 3 radical per second. Radical per second. Okay, and I will throw up the scoring guide. Not throw up, put up. That sounds weird, gross. Okay, so the first one's 3 points. 1 for the constant and limit. 2 is for the integrand. This one here, this one's only worth 3 points. It's a lot of work for 3 points if you can't remember the formula. Okay. And then the last one is also worth 3 points, right? And oh my goodness, look what it says here, answers with units. Units are super important. Do not forget units. All right, quick brain break before we go on to some multiple choice. All right. That was a lot going on. I'm going to drop a poll real quick. If you could only have one ice cream for the rest of your life, what would it be? I'm going with the 3 basic colors, or not colors, flavor. All right. Quick. You've got 30 seconds. 30 seconds. Whoop. Here we go. 30 seconds. Go. Oh, wow. You guys knew. You knew what you wanted. 15 seconds. All right. Okay, lots of chocolate and vanilla. All right. Okay, let's go back in. There was our brain break. Let's go back in. Go ahead and answer this MC question. I'm going to drop a poll too to put your answer. I'm going to cut us off a little early. The answer choices are a little out of order on this one, so you're going to have to think. Oh, and I just took out the right answer. Fail, fail. Pretend where the E is, that's B. Pretend where E is, that's B. Failure. Sad day. Okay, I'm going to close this poll in 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This question was pretty fast. If you put the correct answer as B, you are correct. And why I took out the right answer, I do not know. Okay, so this should be a pretty easy point for you, right? The velocity vector, we know acceleration is the next derivative. Bam, bam, the next derivative, the derivative of x squared, 2t, the derivative of 5t, 5, Hazam, and then we've got to plug in 3, so 2 times 3, and 5. That would be B. Awesome. All right, moving along. Here we go. Here we go. All right, I'm going to give us a minute for this one too. This one should be pretty speedy. I'm going to put a link in the poll in the chat. Poll is open. All right, I'm gonna cut us off. Yes, awesome. You guys are killing it. Good, I see lots of people picking E. Heck yes. You are correct. This one is E. Get it, good job. We're taking our derivative of Y in the numerator would be 2 cosine 2t, and our derivative in our denominator would be 2e 2t. Cancel, cancel. Hazam, that would be, our answer is going to be E. Answer is going to be E. I took out D, but make sure again, this is a chain rule, tricky one. Tricky chain rule one. All right, moving along. Okay, we've got 2 more MC questions. Don't overthink this one. That would be my tip. Okay, here we go. Let's go over this one. We're kind of torn here. We're picking, yeah, this one's a little tricky, but I see lots of us picking B. You are correct. If you are picking B, awesome job. There's a lot going on here. So we want to find dx dt. So if we are going to take the derivative of that, that'd be -10 over x squared. We know that dy over dx, that's dy dt over dx dt. We're going to manipulate this and plug in some information. So we know that dy dt is 3, so we can plug that in here. And we just need to find dx dt still. We need to find dx dt still. Okay, so if I were to manipulate this and solve it, I know that my 2 is right here, so I'm going to plug that in. My 2 is my x value. So I would solve, that would be -12 over 10, which is -6/5. So the correct answer is B, -6/5. Once you get this one started, then it's not too bad. I think just trying to kind of like figure out what they're asking here, that one might take a little bit. Okay, one more MC question, and then we're moving on to Unit 10. All right. One more MC question. I will open up a poll. Last MC question for Unit 9. You guys got this. Your poll is open. "47 seconds. 40 seconds. You got this, guys. Let's do it. "15 seconds. Okay. All right. I'm seeing the answers come in slowly but steadily. All right, guys, you've got 1 hour to go. We can do this. Okay. So this one, there's a lot going on in this one, a lot of information. It's telling you the particle moves on the curve y equals ln x. So the component has velocity x prime of t plus 1 for all x is greater than 0. The particle is at point 1. So we know we want to figure out where the particle is. So we're going to integrate. We're going backwards. We're thinking about position. Okay, so if I'm integrating, I know I'm going to get t squared over 2 plus t plus c. Okay. It tells us in the problem that x of 0 is 1. Remember, this is parametric, right? The first time I did this problem, I did not catch this, and I was like, la-di-da, I'm plugging in 1, 0. This is parametric. So 0 in for here, and we know our x value out is going to be 1, right? So maybe that's where you got tripped up a little if you did. I definitely did the first time I did this problem because I forgot we were dealing with parametric. So my c value is going to be 1. So now I have this x of t value. I can plug in 1. I know my x is 5 over 2. Okay, 5 over 2. And then my y, I know my function is ln of x. So I'm plugging in ln of 5 over 2, which will give me an answer of c. Okay. So just remember on this one, parametric, right? Be careful when you're finding that c value. Easy mistake to make. I definitely made it too. All right. Okay, guys. Whew. Brain break. Take a look away from your screen. I don't know about you, but being on Zoom and online all day, maybe some of you guys are back in person. We are not. Hurts your eyes. Photo of space. Oh, relaxing. Relaxing. All right. Okay, we're in the final hour. Yes, get it, guys. Unit 10, here we go. Unit 10, everything is new. Everything is new. So we're going to do this. We're going to tackle this together. Some reminders here. Geometric series, this is a super fast refresh, so I would definitely go back and review this maybe later. We're just glazing the surface here, dipping our toe in the water. Geometric series is an exponential function. When the rate's less than 1, it's exponential decay. I think it's helpful to picture a graph. When it's more than 1, it's going to diverge, it's growth. And this term, this only tests for divergence, only tests for divergence. Don't put it test for convergence. Sajay, don't do it, don't do it. P series, if P is greater than 1, the series converges. If P is less than 1, the series diverges. If P is equal to 1, it is harmonic and diverges. Limit comparison, remember the limit needs to be both positive and finite. Both series either diverge or converge. Alternating series, both conditions must satisfy. The limit to infinity must be equal to 0. A ratio test, absolute value is less than 1 converges, absolute value is greater than 1 diverges, and absolute value is equal to 1. It is inconclusive. Alternating series is very easy to know because it's got an alternator. That means that should be a clue to you. We've got to use that alternating series test. Ratio test we use when we've got an exponential function. All right. Also in Unit 10, we have absolute and conditional convergence. Conditional convergence converges absolutely when both. It converges when you have the alternator and when you don't. It conditionally converges when it diverges and converges, depending on if you take out the alternator or not. Absolute value. Common Maclaurin series. These are lifesavers, guys. Lifesavers. Lifesavers. I would screenshot this, write this down, memorize them. The key ones to memorize before tomorrow, if you don't have already: sine, cosine, e to the x, and maybe this 1 over 1 minus x. So just these first 4. These last ones you don't really see that much. I just show them to my kids, but you don't have to memorize them. And Lagrange error bound, that is probably almost always on an FRQ and on multiple choice questions. Okay, here we go. Practice AP MC question. 2 minutes. Go, go, go. I'm going to open up a poll for you also. Boop. Oh, I didn't open the poll. There we go. It's like, it's weird. Nobody's answering. Okay. All right. Let's get those answers in. Let's get those answers in. Take a guess at it, even if you're not sure. Looks like we are split between B and D. B and D. All right. This question is a lot going on here. So if you're like, whoa, something to consider when doing this question is a lot of these are looking very similar to one another. They all have x to the n in the numerator, and these first A, B, and C are fairly similar, just depending, it's a little different depending on their denominator. We can pretty much use ratio tests for all of these, right? And we should, because it's asking if it converges for all real numbers. So that means it's talking about an interval of convergence or divergence. If we do the ratio test here, this is not going to converge for all real numbers here. If we check this one out, got our x. The second one is also not going to converge for all real numbers. If we cancel it out, the same in the first one, we're left with the limit. So this limit will cancel out to 1, or go to 1, not cancel out. So you'll be left with x is less than 1. For this second one here, the degree in the numerator and denominator is still the same, so it'll go to 1 also. So you're just left with this. For the third one, for C, same thing is happening here. When we do our ratio test, the limit to infinity, these are both to the 1/2 power, so it's both going to go to 1, right? So you'll be left with the absolute value of 1 is less than 1. For D, we know that this is going to be, well, first off, all of our n's are going to cancel out. So we don't have an n in the numerator and denominator. And if we did E simultaneously, we notice the same thing is happening. So our answer choice just should be between D and E. Unfortunately, I couldn't put E on there because we only have 4 options. So if we're looking between these two, D and E here, E, you're left with E times X. And this one, you're left with 1 over E, or excuse me, X over E. So this bottom one here for E, this will only converge if X is equal to E. This will only converge if X is equal to E on the whole interval, right? So your correct answer choice is going to be D here. The correct answer choice will be D. This is going to converge for all real numbers, this one here. Okay. Again, maybe that's one of the ones that you want to skip and come back to. Since you guys are taking the paper test tomorrow, you can go back and forth. So that one might take a little more time. So test taking tip, maybe skip that one, come back to it at the end if you've got a few minutes left. Okay, try this one. I'll open this one up in a poll for us. Okay, I'm seeing all right. Okay. I'm seeing lots of different answer choices in the chat. Yep. All right. Let's finish this one up. Okay, so this one should be, if we're taking the integral, right? We're taking the integral of this first function and we're plugging in 2 for our function, right? We're plugging in 2 for our function. We are going to get out 0 for our first slope, right? So 0 will be our first slope. So we can automatically take out none of them, none of them. But for our second slope, if we take the derivative of this, if we take the derivative of our second slope, we're going to get -1 over 3 minus x. -1 over 3 minus x. Very important here, again, chain rule. So you might have missed that -1. I'm thinking that's what happened with some of my answer choices, pick an A. For the second one, if we're taking that integral again, we're going to also get -1 for our answer. Again, we've got to do that chain rule there. We have to do that chain rule. So our answer for this one will also be B. Our answer choice for this one will be B. Because that second one is negative. And I think a lot of us put A because we forgot to do the chain rule there. Forgot our chain rule. All right. Here we go. Let's get it. Next question. All right. Which of the following series converges? Let's do this. Which of the following series converges? the following series converges. And I'm going to go ahead and post a poll. Create that poll. Okay, I'm gonna all right, I'm gonna stop us in about 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, I'm seeing lots of choices for D, and you are correct. If you pick D, get it, you got it. Even if you didn't pick D, get it, you got it. You are trying these problems. You are sticking with me for 2.5 hours. You are amazing. Okay, so for A, it's going to converge by P series. 2 is greater than 1. For B, or for 2, 1 is 1, so that's going to diverge by harmonic. For 3, this is an AST problem, alternating series. If we take that alternator out, we take the limit as it goes to infinity. Yes, that is going to be 0, so that is going to converge. So our answer is going to be D. 1 and 3. Awesome. Okay. All right. I'm going to give us a minute for this one. I know it says 2, but I think we can get this one in a minute. I believe in you guys. Got this. Okay. Poll is open. Poll is open. Yes, people are answering. You got 19 seconds. I'm only giving you a minute. I'm challenging us. Okay, that is a minute. Get it, guys, answering it. Yes, we are torn, but we are leaning more towards A. And huzzah, A is the correct answer. If you answered A, good job. Even if you didn't, that's okay. You're still learning. You're with us. Okay, if we're looking at f of 0, and it says we want it to the 3rd degree. So I'm looking at my 3rd degree. I see that it's -5. Remember when I'm writing Taylor polynomials, right? It's over 3 factorial. So this -5 is also a simplified version of that over 3 factorial. So in order for me to understand what the derivative really is, I gotta also multiply it by this factorial. 0. So my answer would be -30. So my answer should be A here. If you pick C, that's great. You're part of the way there, right? You recognize that, yes, -5, that is that coefficient that we're looking for. So you are so close. All right, here we go. Chugging along beautifully. You guys are gonna kill it tomorrow. All right, I'm going to challenge us to a minute for this one too. This is where it's so important to know these Maclaurin polynomials. So important. It'll make your life so much easier. I promise. Okay, opening up the poll. All right. I'm gonna cut us off here. Give us a little more than a minute. I lied. Okay. Which of the following is the best polynomial approximation for cosine 2x? Okay, so since we know that cosine is 1 minus x squared over 2 factorial, plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And we're just going to multiply all our x's by 2 because that 2 is right next to your x of your cosine. So I'm going to rewrite my function. So 1 minus 2x. I'm going to put this in parentheses. Super important because I have an exponent here, right? I know my 2 needs to be right next to my x, just like it is in the given problem. So if you picked, whoops, didn't mean to do that. My computer's going, it's going crazy. 2x 6 over 6 factorial. If you picked an answer other than D, maybe you forgot to distribute the negative, right? So if we're thinking about this, we have got to have, we know it's going to be 1 minus 2 squared over x squared over 2. And we're really only looking for the first term. So 2 divided by 2 will just be 2x squared. So our answer choice here should be D. Excuse me, C. D. D. I was looking at the poll, and our answer choice here should be D. C, it looks like we picked if we just forgot our coefficient. We forgot to square it, right? If we put 2 over 2, and then we forgot to square it there. All right, that one is D. Okay, close the poll. Here we go. All right, we have got a free response. Got a free response. I'm going to give us 7 minutes for this FRQ here. Seven minutes for this one. Okay, about a minute and 40 seconds left here. Okay. All right, guys, finish up your thoughts. Finish up your thoughts. All right, let's look at this Lagrange error bound. And just a reminder, guys, the timing I'm giving you tonight is not the exact timing, right? You have 15 minutes per FRQ. So I'm giving you less than the amount so we can get through content together. On MC questions, right? I'm giving us about 2 minutes because there's lag time with the streaming too. You probably want to spend about like a minute to a minute and a half on each question. Some questions might take you 2 minutes. So just something to think about with timing, right? I'm giving us roughly 2 minutes again, just because of lag. And I know that it doesn't transfer so well online. So something to think about. Okay, so for this question, again, you probably didn't finish it all because I only gave you 7 minutes, right? On the AP test, you'd have double and a minute or so, 15 minutes. So for A, we want to write the first 4 non-zero terms and the general term of the Maclaurin series for F. So it gives you, this problem is really nice because, oh my gosh, it gives you this here, right? It gives you this piece here. So what we want to do, same way we kind of tackled the last question, we want to do x over 3, x over 3, x over 3, x over 3, x over 3. And then we want to multiply everything by x. So I'm just highlighting so you can see where this is coming from, right? I'm highlighting so you can see where this is all coming from. And then if you're simplifying, right, this would be simplify. I didn't simplify it out the whole way. The reason why is because the question is also asking you for the general term. General terms can be difficult to find if it's multiplied out all the way because it's harder to see patterns usually. At least for myself, it's harder for me to see a pattern if I'm multiplying it all out. So my general term, I know it has an alternator. I know that my ends are going up by 1. And since I didn't multiply it out, I can see that it's something 3 times n something and then times n. That's also increasing. Okay. And we'll look at the scoring guide after this question. All right. Okay, so if we look at B, it says determine the interval of convergence for the Maclaurin series. Show the work that leads to your answer. All right, so it's specifically telling you to show your work. So don't forget, very important, very, very important. So we're gonna use our general term here. This question gets a little tricky because if your general term isn't correct, this part here might get a little fuzzy and might not be totally correct. So this question is, this B part does kind of correlate to A a little bit. So again, just something to think about as you're going through the test and taking it, like what strategies are going to work for you. Okay, so I'm doing my ratio test because that's what I always need to do with my interval of convergence. And then I'm going to cancel out what is in common here. So I will be left with xn over n plus 1 times 3. So I know that my interval here could be looking like absolute value of 3. I need to test my endpoints. Remember, you're testing your endpoints by plugging it back into your general term. That's what's happening here. So I'm testing -3 and 3. I know if I plug in -3, it's going to diverge. And if I plug in 3, it's going to converge by AST. It's going to converge by AST. And we will look at the scoring guide after this to see how they're going to award points for this question, because I think that is kind of interesting for this question, for sure. And then for C, it says your polynomial is the 4th degree Taylor polynomial for about x equals 0. Use the alternating series bound to find the upper bound. So remember from A, you found this equation, right? If it's the 4th degree Taylor polynomial, you're going to look for the 5th, right? You're going to look for the one above when you're doing alternating series. So one above. So therefore, we're looking for those coefficients or those numbers, right, in our equation. And we know that it'll be -2 to the 5th. So this has to do with your Lagrange error bound and alternating series test. Okay, and if those are a little fuzzy to you, the videos on AP Classroom, the daily review videos, are really good for alternating series and Lagrange error bound. So I would recommend maybe checking those out if that's something you're still confused on. Okay, all right, guys. We have finished up Unit 10. Awesome work. We've got like 20 minutes to go. First, let's look at the scoring guide before I get ahead of myself. For the first question, it's 2 points. So 1 for the first 4 terms and the general term. So even if you don't get the general term, you can still get credit for the first 4 terms. So you might not be able to do B, but you could totally do C, right? Even if you get the first 4 terms. So B is 5 points. It's a lot of points going on here. So B, you get 1 point for setting up the ratio, computing the limits, the radius of convergence, considering both endpoints and analyzing here. And there's a few ways that they would accept your work depending on how you're going about it. So maybe after the stream, take a look at the scoring guides for this question and you can kind of rate yourself depending on how you did it and how you showed your work. And then for C, that's 2 points. So 1 point for using the 5th degree error bound. So even if you don't get the question right, but you recognize you need to use the 5th instead of the 4th, you can get a point for that. So that's awesome. And then 1 point for the answer. All right. Quick brain break. Take your eyes away from the screen. We've got a Queen Elizabeth meme here. She's doing some improper integrals. She's reminding us that we do not like, when the bounds are to infinity, but we do like it when we take it out and put it as a limit. Maybe stand up too. All right. We're almost there, guys. We're in the last 20 minutes. We made it to the end. You guys are amazing. You stayed with me. Some tips and tricks here. You want to round to 3 decimal places on the AP test. 3 decimal places. Always answer at least some of the question. You never know what you're going to get credit for, right? Even if you don't know anything or you think you don't know anything, you know something. We know you know something. I know you know something. Your teacher knows you know something. Your friends know you know something. So show us that you know something, right? You never know what you're going to get credit for. Just start brainstorming. Start writing stuff down. It may come to you. Don't cross anything off unless you know 100% that it's wrong. The graders cannot grade if you cross it off. So when I graded last year, if the student had the work right, but they crossed it off, we can't give you credit for it. So don't cross it off unless you are like 100% certain that it's wrong. When it's a calculator problem, use your calculator. We didn't do a whole lot of calculator problems. I think we have one or two on the next few slides, but make sure to utilize your calculator, right? It's super important. They don't need you to show all your work. Watch the time. We've talked about timing a few times. You have about 15 minutes per FRQ. Multiple choice, depending on the section, you have about 1 minute and 30 to 2 minutes, depending. I say comfortably, maybe you want to do like 1 minute to 1.5 minutes, which is crazy fast. And remember, you don't need to answer every question on the AP test, right? You can skip around, come back to it. So don't get hung up too long on a question that you might not know, but then you might know another question along the way. Notation is super important on FRQs. Multiple choice, no one's gonna look at your work, so don't worry about that. You don't need to simplify, just a reminder, they're not assessing you on your algebra skills, they're assessing you on your calc skills. Units equals life, 100%. If you don't put your units, oh man, sometimes that's the only point and it has to include units. So make sure that you're including units, and the more FRQs you do, the better you'll get. We just did a ton and we're gonna do a few more. Okay. So let's do this one. Here we go. Gonna give us, I think I'm gonna cut us off at 7 minutes again here so that we have time to do some more. Cut us off at 7 minutes. All right, guys. Okay, I'm gonna pause us here. Let's start going through this. There's a lot on this one. Probably didn't get through all of it. That's okay. Okay, so for here, it's giving us a graph, right? It says the function is differentiable in the closed interval and satisfies f of 2 of 7. It's giving us this coordinate here. The graph of the derivative consists of a semicircle and 3 line segments. Semicircle and 3 line segments. You want to find for A the value of -6 and the value of 5. Value of -6 and 5. So if we were going to find value of -6, this is some fundamental theorem of calculus right here. Plus -6 over -2. And our derivative here. Okay, our derivative here. All right. Then, so we know that f of -2 is 7 because it tells us that in the problem here, right? We know that f of -2 is 7. So we can write 7. And I'm going to go ahead and switch the bounds here from -6 to 2. So I'm going to put my -2 in the top bound and my -6 in the bottom bound. Okay, so that's going to change my sign. So instead of being positive, it's going to be negative. And then if I'm looking from -6 to -2, I'm noticing this is a triangle, right? So I need to find my area under the curve. My area under the curve would be a triangle. So 1/2, 4 times 2, which is going to give me 7 minus 4, which is going to be 3. Perfect. All right, and then we're going to find f of 5. F of 5, kitty. F of 5, if we find f of 5, we're going to do f of -2 plus 5 to -2, f prime of x dx. Again, we know that f of 2 is 7 plus, and then we have -2 to 5. So we have 2 areas under our curves for this one. We've got this semicircle and we have this triangle. So if we calculate the area of our semicircle, we're going to get 2 pi. It's going to be negative though, because it's underneath our x-axis. So that's going to be negative, and then our other value will be +3. So that means we'll get 10 minus 2 pi for our second value. Katie. Okay. All right. Let's take a look at B. For B, it's asking you what intervals is f increasing, and we have to justify. Very important. That means that justifying it's attached to a point value, right? So we know that this is increasing from -6 to -2 and from 2 to 5 and from 2 to 5. And we know that this is increasing. Remember, this is your derivative graph. So -6 to -2 and 4 to 5. These are above our x-axes. These are above our x-axes. So we could say that our second derivative is greater than 0. We could say it's also increasing. There's a few ways to justify that. All right, for C, the absolute minimum on the value in the closed interval, they're giving you this closed interval here because they're giving you a hint, hint, hint. Test those endpoints, test them out. So we know that we have a minimum at 2. We know we have a minimum at 2. How do we know this? Because it's negative to positive. We're decreasing and then we're increasing, right? I have my students usually hold their hands, right? You're going down to up. And if it's a maximum, it's going up to down. So we know that we got to test that point. We also need to test our endpoints as well. Okay. So since it's giving you those endpoints, it's giving you a reminder to test them. So we've got -6. We are going to throw in there also -2, 2, and 5. And I'm putting in -2 in there because it's given for us, but we don't absolutely have to. Handy dandy, we already know what the value is at 2, right? We already know what the value is at 2. Oh, wait, that's a lie. Sorry, we do not know the value at 2. I got excited. From the last problem, we know what the value of 5 is. We know the value of 5 was 10 minus 2 theta. So we found that one out already. We know the value of -6. That was the other one we found on the previous side, is 3. So we can fill that one in. We need to find what 2 is going to be. So we need to quickly do our fundamental theorem of calculus here. Okay, so that will be 7 again, and then minus 2 pi from -2 to 2. We know that's a semicircle, right? We know it's a semicircle. We know that that area is -2 pi. We know that that area is -2 pi. Okay, so this would be the coordinate for f at 2. So 7 minus 2 pi. Okay. So therefore, now we are using this table to justify our answer, right? So our absolute minimum will be at 2 because this is the lowest point. This is the lowest point. Okay. All right. And we can't forget about D. Can't forget about D. So it says for f triple prime of -5 and f triple prime of 3 for your third derivative, find the value or explain why it doesn't exist. So we're going to find our third derivative at -5 first. Remember our third derivative, since this is going to be on our graph, we're looking at the first derivative. We're looking at the slope then. So if we're going to go 2 to 0, -6 minus -2 equals -1/2. Equals -1/2 here. Okay. All right, and then for 3, I'm sorry, I don't know why I put third derivative. That is your second derivative. Second. I'm just looking at the slides. Like, that doesn't even make sense. Okay. Like, wow, that's some high level math there. All right, our second derivative. It's very small. Okay, so if we're looking at 3, there should be some bells that are going off in our head, right? 3, that looks like a cusp. That looks like where our derivative will not exist, right? So we can't just say D and E because it's a cusp. We need to explain why. And it tells us we need to explain why in the problem. So one way we could do this to explain why is we could explain why by the limit, right? So we could say our limit as we're approaching 3 from our negative values, we could say, and we could write out this limit notation, say that this is approaching 2, right? And from our other side, if 3 is approaching from our positive values, that's going to equal -1. And remember, we're looking at our derivative graphs, right? So this is our slope. These values are our slopes here. So if you're like, where are these coming from? These are our slopes, right? So we can see coming from this way, this is a positive slope, and this way is coming at a negative slope, okay? So we've got a positive and a negative slope here. So we know that these two are not equal. So they are not equal to each other, so that second derivative will not exist. That second derivative will not exist. Okay. All right. And just again, to look at the scoring guide here, you would get 1 point for the initial condition, 1 point for each of your answers. 2 points here for answers with justification. C is going to be your absolute minimum, will occur at this point. The table would justify that, right? That would be enough to confirm that point. For D here, if you're showing the slope, that will work. And then they suggested using the limit, which was what I had thought of too, but I'm sure if you have, it doesn't say specifically you get the point for the limit. So if there's another way that you prove it and that's convincing enough, that makes enough sense to the readers, then, you know, that would probably be fine, right? Okay. All right, guys. We're gonna look at these questions together because we've only got a few minutes left. 3 minutes. So we're gonna do as much as we can here. Much as we can on this last question together. All right, so it says the figure above shows these two curves. Let R be the region in the first quadrant, and this is bound by f of theta, and S be bound by g of theta, right, in the x-axis. Find the area of R, find the area. And this is a calculator problem. Calculator. And remember, your calculator should be in radians. Check that now. Check it now. Check it now. It should not be in degrees. It needs to be in radians. Okay, so if we want to find that area bound by R, it's going to be from 0 to pi over 2. We know our area formula is 1/2. It's f of theta squared d theta. We plug that into our calculator. That's going to be 0.64814, right? And we're plugging into a calculator, and we want to truncate that off to 3 decimal places. 3 decimal places. All right. Okay, for B, it says the ray is dividing S into 2 equal regions of equal area, right? But do not solve an integral whose solution will give the value of K. This one is pretty interesting to think about. So if we were to do this, we know that we're going to have 2 separate sections, right? So from 0 to K, because that's just how polars work, you have to think about it a little bit differently than Cartesian. Minus f of theta squared d theta is equal to also K over pi over 2 g of theta squared minus f of theta squared d theta. Okay. So that would be the solution for this one. I'm just going to show, I know it is 7 o'clock and the last thing you guys want to stay on and do is math. So the solution guide is on here also if you want to take a look and finish up that question. Just some final reminders for you guys. You guys are going to do awesome. Don't stay up too late studying. Go to bed, especially People on the East Coast, it's late there. Eat something before your test. You guys got this. Make sure your calculator is in radians. Take a deep breath before you start your test tomorrow. You totally got this, guys. You can do it. You hung with us for 5 hours. You are amazing. Show them what you know. And we are here for you. I'm so excited to hear how it goes. Good luck, guys. Get a good night's rest. Have a great rest of your evening. Great rest of your evening.